Welcome to session 4E. Just a reminder, everybody will remain on mute during the recording. We will open up mics at the end for questions and answer. If you want to ask a question during the session, use the chat facility. This session is being recorded, so just be aware of that as well. The session is The 7 Deadly Sins of CICS Integration. Our presenter is Scott Broad. Over to you, Scott.
Thanks. So my name is Scott Broad. I am a product manager for the HostBridge suite of products at Broadcom. I've been in mainframe for 24 years. Some people will say I'm an old mainframer. Some people will say I'm a kid. I consider myself a middle-aged mainframer. So by saying that, I will say CICS and I will say CICS and I will flip between the two. That's all like how long you've been in it before. I've done everything from level 2 support for ZOS all the way through running a bank's entire enterprise architecture, from capacity planning, design, architecture, building out new data centers. So I know how ZOS works from the core, the code up all the way through all the products. So I can answer as technical questions as we want to get into, or I can stay really high level. So thanks for coming today. This is the 7 Deadly Sins of CICS Integrations. This basically protects everything I say, and it can and will change, especially over the years, as I'll get into. Standard disclaimer. And let's get going. So 7 Deadly Sins. So in preparing for these sessions, I looked up the principles of repentance, and there's a few principles that I think are very important for this session. So the first one that we really need to recognize, and really more importantly, confess that we're sinning. So we're going to talk about some of these suboptimal architecture patterns that we've observed over time. Now, we expect that some of you, most of you, all of you will say, yes, we've had some of these architectural patterns in our shop. And I gave this session at Share and watched around the room, and everyone is nodding their heads on a lot of the things that we talked about. So we'll also talk about some suboptimal ways of thinking that leads us to repeat these patterns and not detect them, or in a lot of cases, just plain ignore them. Now, the second principle of repentance is sorrow, feeling bad for what you did. And that really works well over having a beer. And over in the UK, I think it's almost about that time, and this is being recorded. So I don't know when anyone's going to watch this in the future, or at the next in-person GSC, we can discuss all your sorrows over that. Now, the next one, the other principles we have are express regret, commit to change, and make resolutions. Change, that's really what our goal is. Now, don't worry, we're going to give you some hints and some tips on how to address and find a lot of these issues that we're going to bring to light and make those changes. I also want to keep everyone to keep in mind that there aren't just 7 sins. We picked that number, so it sounds good. When this idea was originally thought of, we had a lot of things. We have a lot of different subpar integrations with CICS, and they kind of come and go over the years, and we've all done them. Some of them are active, some of them we did in the past. Now, some of the sins we talked about that we're going to talk about today were brilliant ideas back in 2012. It's really just a matter of timing. No one is saying that they were always bad. The trouble is we don't go back and look at the patterns we created 20 years ago. And I'm not trying to create a lot of angst or anxiety here, but I just want to put our fingers on some of the things that we would call anti-patterns today in 2024. And when I give this session again in 2025 or 2026, it's going to evolve, just like your environments should be evolved. And finally, we're going to forgive those sins once you make those changes. Now, I'd like to start off with why we should care. Now, I think everyone has seen these type of slides before, right? Mainframe footprint is growing, and one of the things that I really enjoy when I go into customer shops is especially customer shops that have like a cloud-first strategy. And many of the companies that have this strategy are convinced mainframe workload is going away. Yet every year they have double-digit MIPS growth. And the reason for this is the enterprise and the technology. So we have tons more mobile devices, more web applications, and it's allowing people to have a more intimate interaction with the company. which in the end, we all know hits the mainframe as back-end transactions. So as you become more and more of a cloud-first company and have double-digit mainframe growth, people are surprised. Now, that's all good MIPS growth. MIPS add value to the platform. We all want to see that. So what we're going to talk about today is if we don't have good or if we have bad integrations, we have the second types of MIPS growth, undesired or unnecessary growth. Taking a look at this slide here, this is taken from one of the world's largest databases on tech and economics. It's comparing costs between mainframe and the distributed cloud, right? So what they're recognizing in a nutshell is, yeah, it's very cheap to get into cloud and move workload over, in the beginning. Very easy spin up, right? But as more workload moves over, the cost increases substantially. At about 3,500 MIPS, that's your break-even point. Once you start to move more, especially if you move the workload of like a mid-sized bank, not even the larger shops, but just a mid-size, you're looking at a 3 to 5x cost increase. So we want to make sure that the cost of the mainframe remains as low as possible. And looking at the trend curves, cost continues to go lower per MIP. And one way we can do this is by looking at how we can optimize integrations with mainframes and applications. And that's where we're coming in today. So let's get started with the first set of sins. Failure patterns. Sin 1, or anti-pattern number 1. This is something that my team sees time and time again. It's a pattern, or I like to call them anti-patterns. It's almost an inevitable result of other decisions that non-mainframe platform and services orchestrating very fine-grained mainframe transactions. Now, we've looked at way more SMF records than most people ever need to look at, ever, and we see this in spades. In fact, if right now, we're working with a top 10 bank, and over the last few months, and they have an entire infrastructure built in MuleSoft, sitting in that integration layer that we see here, this integration layer. Now, it has one purpose: to resolve a mismatch between the APIs that are available on the mainframe and the APIs the client really wants to see. It's a gigantic investment. There's servers, software, people, resources. The results of when you do this, you have a single request that explodes into thousands of more fine-grained requests once it hits the platform. And the cumulative CPU time of handling all of the overhead associated with those requests and the responses can actually be greater than the CPU time spent running the actual target transactions. This is a real case scenario, and this really happens. Now, sin number 2, this is something like sin number 1 on steroids. So what I've done here is change the target application. And now I'm specifically referring to them as screen-oriented transactions, right? Now, we all know these. 3270 transactions, terminal-oriented. Now, I've asked a lot of shops, I've asked a lot of organizations, when we talk about screen-oriented transactions, and you have no idea what we see when it comes to the things that we see that are orchestrating a lot of these screen-oriented transactions. Now, there are a lot of shops that will say, oh, we don't have it anymore. We don't use the green screen anymore. But then we do a little bit of digging, and they just don't know it. Or there was a screen scraping app or a screen scraping solution that was built 15 years ago, which was great at the time, but it has never been updated. So let's talk a little bit about screen scraping. So screen scraping is alive and well. And here it is, and we see it day in and day out. There are so many organizations that are using it. Now, most of us have been around long enough to know about 20 years ago, IBM and CICS put out a call to separate your presentation logic and your business logic. Now, presentation logic in a separate module that cleanly calls over a link to a common area COBOL code that touches business logic. Now, some customers did that, but not every customer has gotten there. And this is well over 20 years ago. So we live in a world where you would just not believe what we're seeing day in and day out. screen scraping still exists. Now, I'll show you some of the things that we see using a tool we have. We see brute force techniques. We see macros and scripts not understanding how CICS work. We see scripts that model terrible end user behavior. And there's also a new, or relatively new, thing called an RPA. Normally I'd ask everyone in the shop or in the room, who knows what an RPA is, and more importantly, are you running RPAs? Our RPA is a robotic process automation. Now, is an RPA cool? Yeah, in the corporate world, it's really cool. It does a lot. But when you open the learning path to UiPath, so UiPath is like the market leading platform for RPAs. And you ask, you go to their site, the knowledge base, and ask, how do you write a bot to use the mainframe? Well, what it does is it guides you through a process of opening a 3270 emulator to screen scrape a demo transaction. So what do developers that don't know anything about mainframe or individuals then attempt to do? Yeah, they do the exact same thing. So think about it. Everyone here in this room, everyone around me, whether you know it or not, has RPAs running in your environment. It's a $5 billion industry and it's growing. It's everywhere. Now, one of the reasons it's so prevalent is they make it super easy to solve the problem that you're trying to call, and you have to update several systems, integrate with those transactions. They make it really easy to use these screens. So one set of automation created, the result is going to be the wrong architecture, but it's the easy path. You can do it right, and we'll talk about that later on. But the easy way, and the shadow IT, people that aren't in IT telling us what to do, they're encouraged to do it cheaply, quickly, and in a suboptimal way. Now, when I give these presentations or when I talk about CICS and orchestration and what we're going to be talking about for the rest of this session, I talk to customers at all different skill levels, right? But here, being a GSC, you likely have a lot of experience. You have a commitment to learning how to improve your skills. You're taking time out of your busy schedules to learn new things. And I really commend you for that. And thank you for watching this, joining this, or watching it in the future. However, that's not true everywhere. So sometimes we have to take a step back and remind people of all the software components and layers that are involved in these integrations that we're doing. When you actually transit in to the mainframe to run a simple CICS transaction, it traverses all of these layers that we see on the screen. And although they've been optimized over decades, they still take time and resources. So we had this chart to show what it takes to go from an end user, whether it's a mobile device, an Excel spreadsheet, a web application, all the way through to the CICS transaction. It's a lot of overhead, a lot of latency. You're driving CP. When you drive network traffic drives CP. So some customers have really lost track of what that path is. Now, when you write a bot, an RPA, to run 10,000 transactions, let's say at a sustained rate of 10 per second, you have a real overhead problem on your hands. Now, I'm going to show you some real use cases of this. This is such a problem we had with the customer. A customer came to us and said, I have a visibility problem. I have no idea what's happening in my environment. I suspect what's going on, but I have no idea. So we talked to the customer, and honestly, we just didn't know if there was anything that can look at exactly what their issues were. So we invented one. So we came up with an analytic platform to do that. So gathering SMF data, we move it down to a proper analytics platform, does some light AI and ML in order to show what this user behavior is, to learn about these 4 CICS integrations that no one knows about. We're trying to figure out what the business object is, what the task they're trying to accomplish. So someone in the organization can look at that data and say, oh, wow, this is what they're trying to do. So this is the method of our madness. We take, you run exits in CICS, so you just take SMF data, and you send the data, and we look at it, we run a report, and we go over a lot of the integrations that we're going to see. Now, some are easy to remedy, and whatever product you use, we're going to talk mostly about, the technology itself. So I'm going to show you some real use cases of these RPAs running out there. This is a huge problem, and we're going to go here. Here we go. All right. So here's the one example. So this is just a bunch of data. And if you're familiar with CICS or the inner workings of RPAs, you might see there's some familiarity here. But this is an RPA bot that we found that ran for 22 minutes and 30 seconds. Now we're able to detect it by doing just analytics on CICS 110s. Pretty easy, nothing special. The bot ran 10,503 transactions. It ran at a sustained rate at 7.8 transactions per second, about once every 125 milliseconds. Now, this is also going across a nationwide network, bouncing between data centers between Dallas and Chicago. The actual transactions only took 1 minute and 33 seconds. So where did the other 21 minutes go? It's 21 minutes and 30 seconds, but the transactions only took a minute and a half. They went to network latency. So a little bit more information. Those 10,500 transactions took 27 seconds of CPU time, which on a modern ZBox is actually a lot of CPU time for this. Now we often dig a bit deeper. This is kind of one of our favorite things. If you enable exits, we enrich that SMF data with a bit like the PF key and enter keys in the O1 and OA data fields. Then once we have that enriched SMF data, we can map the pathway through the transactions. In this case, it was the enter key. So we figured out in this case here what this bot was doing. So what it was doing is there was an Excel macro in a spreadsheet distributed through every office, and it was the macro that determines if an order is completed. And you know how it did this? It pressed enter every 100 milliseconds until a message came up on the BMS screen. So that's 27 seconds of CPU time based off of the enter key waiting for a message. This is a suboptimal integration. This is a poor macro, poorly written macro. Now we also store a lot of this data and do longitudinal analysis across. And guess what consumes more CPU than any other business process in this organization? The enter key. Now, at a different customer, we discovered this sequence. We found a bot that was doing this all day long. Now, if you're looking at this and you're an experienced CICS person, I hope you're looking at this and wondering what is going on here. Sometimes it takes a curious human to discover a bad bot. On what planet and what application is it required to press the clear key back to back? And why would you be exiting application state and re-entering? This is a real bot that's actually still in production in an organization. What it was actually a HACS application. And what it was doing was gathering information for a home screen of an application. And every time you get back to that home screen, the macro runs and regathers all that data. Well, the developers of these macros, they wanted to be good programmers. They wanted to be a good citizen. So they said, it's not really one thing we need to do, it's 5 things. It's 5 sub macros. So they sat down and wrote these. And each of these macros defended against the bad citizens. So they would be good citizens. They thought they were doing something great. But in so doing, they wanted to leave the transaction in a proper state. So each one cleared the screen, ran 2 transactions, and cleared the screen, and on and on and on. This sequence ran more than any other sequence in their organization. And they wondered why their Z15s were at their knees. Now, it wasn't me at the time, but this story came from Russ Tubner, who's currently DE at Broadcom, but he was originally the founder of the HostBridge products. He went into the meeting and he said it was the least fun meeting he's ever had. he had to tell the deputy CTO of the organization that 50% of all CICS interactions had no functional or business value. You can imagine how that conversation. That's just a bad bot. But they thought they were doing good. So we'll move on to modern CICS architecture and RESTful APIs. RESTful APIs, always good. We hear the terminology, they're awesome. Now, yeah, some are great and there is goodness there. But we believe that in 2024, this is again contextual, because 10 years ago was a lot different. But in 2024, starting your API journey with the question of, what do I have that I can expose? This is the wrong question to begin your journey with. The bottom-up thinking was a decade ago. Let's put an API on this COBOL program. But what happens is there's a mismatch between the needs of the business and the APIs that are exposed if you're just focusing on the individual artifacts. This is a real use case study. Here's a financial institution that built a new mobile application. On the mobile app, they want to get a synopsis of all your details. So account info, if you have mortgage accounts, checking accounts, money market accounts, you get the idea. So if you have 5 accounts, it makes 5 calls. So on the right of this chart, it's not the those APIs. That's not the API, right? Those are the APIs for the individual programs. The API that they're using is actually on the left. So what do? Well, there's an impedance mismatch between the needs of the business and the APIs that could be fielded just by the nature of the artifacts. They created layers of integration. Now, either on the integration layer itself, sitting on the app server, or all the way out on the client. Now, along the way, IBM and the CICS team came up with some really great tools, at the time at least, to expose things like common area programs. And they were brilliant, never, brand new. It's really cool. And there's nothing wrong with them. And we all used them, 10, 15, 20 years ago, and they worked. But the reality is when you start with that bottom-up thinking, the needs of the business are different than the tech available, the technical availability. And you end up with this mismatch, and you're destined to land somewhere on this diagram. Now, every time we look at SMF data, whether it involves old school CICS transactions, or more recently, CICS web support APIs or ZOS Connect APIs, this is what's happening. So, where we go from now? So orchestration. So now we're always going to be the first to say that orchestration is okay. When you have a business process that needs to do 15 transactions, it's a lot easier to orchestrate all that, right? You want to make sure it's one call, easier for the developer to do. You're always going to need to resolve these mismatches that we just spoke about, and orchestration is a good solution. But the question comes down to where. Now, we're all mainframers, right? You could probably already see where I'm going with this and what I believe. Do we do it on platform or off platform? Well, if you do orchestration off the mainframe, now I know I keep bringing up this slide, but it's for good reason. It's a really powerful slide. When you do it off the mainframe, you're doing all your orchestration, let's say either on your client or your app server, or even on your integration layer. Network traffic and latency goes up. Mainframe overhead goes up. It adds a whole new level of cost and layers of abstraction into the organization. Your quality of service goes up. Now, if you move it on the mainframe and do all your orchestration on platform next to the artifacts themselves at machine speed, you're going to minimize all that traffic. And for one thing, you create the impression that the mainframe application is sensitive to the needs of the business. So we're fielding an API that our customers actually care about, not just based on the fact that we have 5 COBOL common area programs and that's what we do, put a tiny little API on. And we create the orchestration here on platform. And not only that, it can run on the zip. When you do this and running it on platform, your network and latency goes down, your mainframe overhead goes down, and your quality of service goes up. Now, if you read between the lines on that, that's a cost, that's a real world cost savings because network traffic drives mainframe CP. So here's an example of orchestration. So how do we do that? So I'm going to give you two examples. One happens to be our approach, but there are many approaches. For example, we were in a conversation with a very, very, very large financial institution. They have a huge commitment to Z and a large commitment to Java and very skilled resources. They run Liberty, sometimes under CICS, sometimes outside of CICS. And they create Java programs to be able to resolve those mismatches. The API lives here on the right side, within CICS or within, yeah, over here. Oh, nope. Within CICS. And it fires off a program and it gets control. And here it issues JKICS calls to execute the necessary CICS programs, aggregate the data, massage it, strip it, and then boom, send it out. There are products that do these things. Here I mentioned Liberty. HBJS is shown here. Use JavaScript to describe that orchestration. But I want to stress it's not about the product itself. The point I'm trying to make here and stress is that we do it on the mainframe. However you do it, orchestration on platform. And the reason we're showing these examples of orchestration running on the mainframe is because it's the orchestration of rapidly running transactions on platform. Instead, look at the broader rule. Orchestration should really be wherever, as close to the applications, as close to those transactions as possible. If the transactions are happening outside the mainframe, put the orchestration outside the mainframe. But that chattiness, no matter where it is, the chattiness across the network really should not happen. You want to move the orchestration as close as possible to the transactions and the artifacts and the data itself. So far, these three orchestration patterns are all very common. They all vary on orchestration patterns. And now we're going to go to the next sin. We're going to look at cost cutting and the technology choice. So this is another anti-pattern that we continue to see whenever we look at customer SMF data. So a number of years ago, the CICS team came out with a lot in the industry, thought was great for that time, and it was. I mean, the web services agent, generate whistles, allow you to generate SOAP documents, and the XML schema to invoke all these services. It was really progressive at the time. It was cool. However, over the passage of time, I think we all know that SOAP and XML as protocols are looking a little heavy compared to a more lighter weight approach like a RESTful API and JSON as the vocabulary. So our rule of thumb is don't use heavyweight protocols if you don't need the value of the protocol. I mean, SOAP was brilliant at the time. And a lot of that had to do with the ability to manage or allow you to do things like QoS. But I don't know anyone, I mean, I've never seen, especially in CICS, anyone using the manageability of QoS within the protocol. So go back and take a look. If you're doing this today, you just need to go and download ZOS Connect, really rethink the whole thing, move away from the heavyweight patterns and move to much lighter weight protocols. So where are we? Let's see. All right, the final sins. So going back to the first few, we've talked a lot about this from the latency and the performance perspective, which goes to cost, right? But when you're selling this to the application side, it requires changes for basically the full application development team needs to make in the interfaces. When you move to these business process oriented APIs, it's much easier for developers outside the mainframe to wrap and adapt those business services because they no longer need to deal with the complexity of how CICS was organized 20, 30 years ago. It was what was available back then. It made it really hard to build these applications. Now, I just want to pause here real quick. I know it's hard on Zoom and to have a really true interactive session. I really like taking questions and during the session and watching people realize what their environments look like now. But I hope this all makes sense. And if these are patterns that are something you're seeing out there, that's great, and we'll definitely look into trying to solve them. So why is it not obvious or detected? Or more importantly, if they're known, why is it not acted on? Right? If you're thinking right now, we do have some screen scraping applications. Why don't we move forward? These anti-patterns or sins aren't just errors in your implementation. They can just be errors in the way you're thinking. And what do I mean by that? The way you're thinking. Sin number 5, optimizing only the silos. So what does this mean? So remember that one example of the customer that had an Excel macro that pressed enter key 10,000 times? That's like my favorite example. All it was doing one thing, pressing enter for a business result. Well, when we first showed them that, my colleague was on site and they immediately went over to the application folks. And the manager had a conversation with them about this macro, this application. The application developers were proud of it. Our transaction runs 20 million times a day. Compiled with COBOL 6, it runs from wherever, anywhere. We optimized our silo. We are really happy. That's cool. Went over to the CICS team and said, are you aware of this? No, but we've optimized our CICS regions where we run with 3 TORs over here, a DR system with TRRs over there. We can handle this load easily, optimized. Went to the ZOS sysprogs, gold star. Capacity planning, gold star. Everyone optimized their silos. Even the network capacity team, they got extra capacity between Chicago and Dallas. Good, they handle it. But it took someone finally asking the question, a business question. We book 80,000 orders a day, and we run 25 to 28 million transactions. Why? Now, if there was someone in the room, someone usually says, well, the reason is a business transaction is a lot different than a mainframe CICS transaction, sure. However, the bigger answer here is rogue automation. Automating transactions extremely inefficiently to accomplish a business process. Now, there could be good reasons, and there could be terribly bad reasons. Usually, the organization's first clue that something was wrong was the business was growing around 5 to 7% per year, but their transaction volume was starting to reach asymmetrical proportions. They kept seeing this growth rate differential between the business orders and transactions go like this. If you ever see that, you see your business growth and your mainframe resource growth not going in sync, start asking those questions, because it takes someone to see the entire picture, not just those silos. Sin number 6, tolerating microservices, or not just tolerating them, justifying them, saying we're right. With one customer, and this chart is exactly what they were doing. They were coming through an integration layer, going and getting all of these programs and individually doing what it needed to do. There are these little microservice APIs on each of these programs. And what they were doing was putting data on the screen of their app. They were using ZOS Connect to do this. So as we said, since you have a team of programmers, what do you think about creating instead of creating an API for each one of these, why don't you use your programmers and write one program that can act as a wrapper, put like a composite API, and then just link to all those programs. One call. We thought that was a great idea, and that's a best practice for that at that point. They disagreed, and they said, we like it this way. This is consistent with our view of microservices. Their thought process was small is good at any cost. Well, we were kind of dumbfounded. We didn't know what to say because it's just not true. But there's that mindset. They're tolerating, they think it's the way to go. Now, if you don't really know microservices or want to understand more about microservices, there's a great read that you can take offline. Write it down or Google it. Google Amazon Prime, The Return of the Monolith. If you haven't read it, it's great. Basically, it's Amazon Prime Video falling on their own sword and saying, we ate our own dog food and created a mess. They ingested microservices and realized very, very, very bad idea. So it's a great read if you want to take the time. Sin 7, final sin. And talking to people in here and at GSCs and shares, it's usually, these are, it's like talking to the choir, experts in CICS, expert in CICS. However, many times we're not preaching to the choir, and a lot of the times we're not even talking to mainframers. So we just want to highlight that sin 7 is thinking CICS applications can't be first-class citizens. It can, they should be, use them. But sometimes the reasons organizations don't think they can be is that the means and modes of the integrations to them don't really taste, smell, or act in any kind of a modern way. And that has a lot to do with the mindset. And things that were done 15 years ago are still considered best practice. Our goal is to make sure all of customers, all of our organizations think CICS applications are really first-class citizens. And there are some very sound best practices out there. Listen to them, use them, don't ignore them. I'll close this slide with, I hope over the years and the years, as we see more data sets from customers and we see different things, there's going to be an interval of time where we don't see some of these bad integrations and we see good things. And I hope we get to a point where organizations are doing orchestration, or more importantly, on platform rather than off. So to wrap up, we've talked about a number of technologies here, but the key thing to take away is not the technology that's bad in most cases. Sometimes we have better technology. And I hope showing these examples and use cases and real world problems of how everything's been applied helps. Have those conversations with your application teams and others. And it's often very difficult to detect the problems that we've talked about. We can help. We have tools that do the analytics and detect at least some or all of your biggest anti-patterns or macros that could be problematic. It could be as easy as sending us a couple hours of SMF data, or within a few days, and we'll come back and show you what we observed. And we can point you in a direction of how to remedy those situations. Today, we've talked about systems using a lot of mainframe. That's why we're talking about orchestration on mainframe. And there are a number of ways to create this orchestration. Not about the product, it's more about the tech and doing it on platform and orchestrating a lot of these services. We think we have a good one with HostBridge. It allows you to build the JavaScript API. But there's many tools out there that allows you to do this, and using those tools to build your orchestration without having to change COBOL or the underlying application code, it really helps, and it can really benefit your business. So with that, thank you very much for attending. I will pause and open up for questions if anyone has any. I don't see anything in the chat.
Thank you, Scott. Let me just allow everyone to unmute themselves in case somebody's desperate to ask a question. Just bear with me a second. Okay, so I think everybody in the session is now able to unmute themselves. So we'll just pause for 10 seconds or so for anybody who wants to come off mute. Okay, I guess not. Well, thank you, Scott. That was very thought-provoking. Thanks for sharing your experience and expertise. I think there's something to take away for everybody there. key thing at this point is we need feedback for all sessions, and as Scott is showing here, there's a feedback link for his session. If you want to provide the feedback later, the easiest way is to go to the Bring Your Own Agenda page on the GSE website, and there'll be a link there to Scott's session. Thank you all for attending. We have one more CICS session today. It starts at 4:30. It's with Andrew Smithson from IBM. Who will be presenting APIs from your CICS applications, effectively how to invoke REST APIs from your CICS applications. So with that, final thank you to Scott, and thank you for everybody for attending, and hopefully see you at 4:30. And I'll now close the session. Thank you.